Today we are going to take a look at one more interesting problem from Codeforces, which is gerrymandering. And in case you are wondering what this term means, gerrymandering, it means like manipulating the boundaries of the electrical constituency so as to favor one party or class. That is gerrymandering basically. So heading back to the question. Now, question is given that Alvaro and Jose are the only candidates running for the presidency of Tepito, a rectangular grid of 2 rows and n columns where each cell represents a house. It is guaranteed that n is multiple of 3. Okay. And then under the voting system of Tepito, the grid will be split into districts which consists of any 3 houses that are connected. So each house will belong to exactly one district, yes, and each district will cast a single vote. The district will vote for Alvaro or Jose respectively if at least 2 houses in that district select them. So it is like majority, and therefore total of 2n by 3 votes will be casted because there are because there are n n columns, and each column has uh, 2 states or whatever it is, and 2 cells, and each group will have 3 cells. So therefore total of 2n by 3 votes will be casted. Okay, so now heading forward, and as Alvaro is the current president, he tries to gerrymander. Okay, so he knows exactly which candidates each house will select. So Alvaro divides the houses into districts optimally. Then we have to determine the maximum number of votes he can get. Yeah, so cells are connected if path between any 2 cells requires moving only up, down, left and right. Okay, it is like Manhattan distance or something like that. Then let's take a look at first test case. So first test case is like 3AAA 3 A A A A J J. Now if Alvaro tries to divide the districts like this, and the maximum number of votes he can get will remain as 1 for upper rectangle. But if Alvaro tries to group them like this, and like this, then he can get maximum of 2 votes. Then he can get maximum of 2 votes. So we have to optimize how he divides them into the groups of 3. So we can observe that groups of 3 can be divided as like this, like this, like this, or this. And again we can also divide it like 3 rectangles this way, this, and here are the possible choices how Alvaro can divide the districts. And one more observation, if we start from the last, he cannot divide it like this, because this J will not be accommodated in any of the district. Okay, so this is not allowed. Similarly, this is also not allowed. Okay, this is not allowed because this will not be accommodated in any of the districts. So here we can notice that this problem, if we see, suppose this is our 2 into n grid. So basically here n is divisible by 3. Suppose if I take out this part from the grid. Suppose Alvaro divides this like this, and this part is the second part. He divides like these three cells will form a district. So our answer will be like the maximum vote that Alvaro can get here in this thing, this divided district. Suppose we calculate it by function check something 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 arguments plus the answer which we will get in this place. Here one cell and here whatever. Here we had this thing where total columns were n. Now they are n by 2, n minus 2, n minus 2. Of course, this is one half column, but we are considering full. So considering this way, we can also divide this thing. Suppose like this is there. We can also divide this thing like this. So we will get this. Now suppose here n columns was there. Now here there will be n minus 2 columns. Of course one half column is there. So again we will check for this district which was there and which was partitioned. We will check what Alvaro can get from here, and then our answer depends on only the remaining part. Okay, so this kind of reasoning gives us that we should use DP in this problem to solve it. Okay, suppose I'll define some states. Suppose DP of n. So okay, DP of I is the number of columns, and state is basically characterizing the shape of our remaining part. Suppose this is the remaining shape, there is no half column there, then I will assume that state for this is equal to 0. And if suppose one half column is there, that too on upper side, I will assume it as state 1. And if it is, if the half column is containing the cell which is downside, I'll consider this as state 2. Okay, now what are our transitions of DP? Okay, suppose here in state 0, this Alvaro can select this thing. I will write it here, this thing. Then he can select the whole three of the adjacent cells which are horizontal like this. Now if he selects this, then automatically downward 3 cells will also form a district, because there is no other shape that fits, right? So if Alvaro selects this, then we get state 1. Okay, state 1, which is having upper half cell. And if Alvaro selects like this, then we will have state 2. Okay, so transitions for state 0 are completed. Again same for state 1. In state 1 he can select this from the last, this thing, or he can select these 3 and these 3 completely. Okay, so this thing and this thing for partitioning of districts. So state 1 is also completed. For state 2 transitions are, he will select this or this horizontal 3 and then this horizontal 3. Okay, so this is basically the solution. We try to calculate this using DP. So let us head to the code. So here I am using this type def long ll, and then this is my check function. Basically my check function is checking whether that district will vote for Alvaro or for Jose, and it is written like, suppose check function is written as, it is taking 6 arguments a, b, c, d, e, f, or you can take i1, j1, a2, j2, and i3, j3, where i1, i2 or i3 means I k suppose, or I r's are 0 or 1, 0 or 1, 0 or 1, signaling that if it is 0, the cell is from the upper half of the grid, and if r is equal to 1, it is from the lower half of the grid. Okay, so and b, d and f, b, d and f represent what number of cell in that half of the grid is it. So heading back to the code, that is basically chk function doing. And next, this is our solve function. In solve function, I'll explain you what I'm doing. So basically taking two inputs, and this is the very clever way to do this, ensure this one based indexing, doing str1 is equal to some wild character plus str1, str2, like same thing, and initializing dp here. The maximum value of n was stated as like 10 to the power of 5 in the question, right? Yeah, 10 to the power of 5, and our states are 0, 1, 2, so j is less than 3. It will initialize all the dp's to -1. And for the base case of dp, see here, all these blocks will somehow get reduced to either this block, means only one full column and one half column, or either this block, right? Try to visualize this in your head, or it can get reduced to nothing. Nothing means 0 columns. Suppose 0 columns. So how is it possible? Suppose 3 by 3 grid was there, and we select this and this, then 0 will be remaining, means 0 number of columns. Here it is 1, and its state is also 1. Here it is also 1, and its state is 2. So initialize base cases. So dp of 1 comma 1, which corresponds to dp of 1 comma 1 is this. So that's why it is labeled as check of 1 comma 1, 1 comma 2, 2 comma 1. Means this is 1 comma 1, 1 comma 2, 2 comma 1, and 2 comma 2. So it is 1 comma 1, 1 comma 1, 1 comma 2, and 2 comma 1, like this. Okay, so that is the base case for our state 1. Similarly for state 2, I am initializing, and these are some debugging steps that I did, and then calling solve of n comma 0. So 0 is basically the state, because initially our whole grid is in the state 0, so calling based upon that. And in solve function, if dp is pre-processed or already calculated, I am returning it. And if I is less than 1, when will I be less than 1? I will be less than 1 if this case happens. Okay, if this case happens, so then answer will be 0, right? There is nothing remaining, so I am returning 0, then initializing answer. If state is 0, I am doing this transition and then this transition. Basically, if state is 0, I am doing these three transitions, if state is 1, similarly I'm doing these two transitions. Accordingly I'm passing the what called solve of, means I'm updating this thing, number of columns it will have after the partition, that related partition. So same for state 1 and state 2. Then finally I am updating dp of I comma state as answer and returning as answer. So that was it. Hope you enjoyed the video. This thing also can be optimized by checking if uh, checking if 2i minus 1 percentage 3 2i minus 1 percentage 3, what is it, it can be somehow optimized. I have not done that optimization is in my code or my solution, but it basically passed on the edge. See, this time limit for this question was 2 seconds and my code passed in 1983 milliseconds, basically 1.983 seconds. So it was not so optimized code, but yeah, it works. The logic is same for the optimized code as well. And hope you enjoyed the video. Stay tuned for amazing code forces or competitive programming questions, and see you on the board. Please subscribe and like the video. Hope I see you on the board again. Stay tuned.